Welcome to section 5.7. We're going to continue on with our differential equations that we're going to be solving. This time we're going to find the general and the particular solutions. General means you're still going to have a C. Particular means they're going to give you a point and there will be no C because you will be able to find out what that constant is. So looking at our slide here, this is the first one. Now notice they said general solution. We're solving a differential equation. It sounds big and scary. It's hard to say too. Differential equations just means you have a derivative. Solving means you're integrating it and solving for y. So on our first example here, I'm going to divide both sides by y and multiply both sides by dx. So I end up with dy over y equals dx over x. I'm going to integrate both sides. Once you have it separated, you are going to integrate it. Well, dy over y, dx over x, that's just the natural log of the absolute value of y. That's going to equal the natural log of the absolute value of x plus c. Then we're going to solve for y, so we're going to have to e both sides. So we end up with the absolute value of y equals the absolute value of x plus some mystery constant. Oops. Sorry kids, hold on. Gotta go back. Okay. Now, on this side, I made a mistake like many other people make a mistake in that we feel like we can just go ahead and rewrite this as the natural log of x plus c. We really can't because of the plus c. What we can do is rewrite it using our properties. Okay, because whenever powers are added, that means we multiplied them. Now we can simplify this guy, but we couldn't before. We are going to simplify. We're also going to drop our absolute values. So we have e, natural log of absolute value of x is just going to be x, so positive, positive, that's why we can drop those. And then we have times our c. Remember, we're just relabeling. Let me pick a different color here. We are relabeling these guys. Okay. So once again, you can put the little sub 1 there so that when you rename it, you think of this as a different constant. It's perfectly fine if you want to do that. I get kind of lazy and I don't. Okay. So not too bad. But today it's going to get a little trickier. The equations are going to be, or the integrals are going to be a little more difficult. Like example 2 here. I'm going to cross multiply. Okay, so that's gone. Look at my integral here. Oh my goodness. If we were in class, I would tell you I would do the left side and you guys got to do the right side. But seeing how we're doing the video, I guess I have to do both sides. When I'm looking at the left side, that integral is good to go. It's beautiful. On the right side, it is not beautiful. I'm going to need to do a u substitution. And this time it's not quite so baby. I need to set what's underneath there equal to u. So that means du, I needed a negative dx. Well, I don't have the negative, so I'm going to put that in, counteract that. And some of you have noticed I have x left over. I've got to back substitute so I can get rid of that. Well, if u is equal to 5 minus x, then that means x is equal to 5 minus u. And I'm going to rewrite the integral on the left side. Let me change it back to red here, there, okay? So then that's going to become, I have that negative out in front. My x is 5 minus u, and then I've got square root of 5 minus x, which is u to the 1/2 power, du. Need a little bit more work here before I can get to going with my integration. So 5 times u to the 1/2 power is 5u to the 1/2 power. U times u to the 1/2 power is u to the 3/2 power. Now I can integrate that. The left side, nice and easy. The right side, not so bad. I'm going to be taking all the u's and adding 1 to the powers, dividing by that same amount. Okay, so that's going to be u to the 3/2 power times the reciprocal minus u to the 5/2 power divided by 2/5, which is the same thing as multiplying by 2/5, plus c. I've got to take that negative through, and at the same time I need to substitute that u back out. So this is going to be negative 10/3 5 minus x to the 3/2 power plus 2/5 times 5 minus x to the 5/2 power plus c. Yay! Now in number 3, they get a little goofier, and sometimes they get hard to see. You've got that y prime right there. You need to substitute in your dy over dx so that you can separate and integrate, etc. I first want to solve for that dy over dx, so I'm going to go ahead and take this guy over. So I'm going to take this guy over to the other side and rewrite. Try to get things in a nice order here. It's negative. Divide through by my negative. And now I want to get my x's on one side, y's on the other side. It doesn't matter what side you want to pick. I'm going to divide both sides by the e to the negative y. Woo, I am writing super sloppy today. I apologize. E to the negative, oh, that wasn't much better. Look at that. So I'm going to divide that. I'm going to divide by cosine squared and multiply by the dx. So I'm going to have sine over cosine squared dx. You will always want to simplify if you can. Before you integrate, see if you can rewrite this somehow, some way. Well, notice on the left side I have that negative y power on the bottom. Well, why not just move that up? Then it's e to the y dy. That's something easily integrated. Sine over cosine squared, that's my sine over cosine times 1 over cosine. That's tangent times secant, which is also easily integrated. When I integrate that, that's going to be e to the y equals my secant x plus c. And then I have to natural log both sides in order to solve for y. So my final answer is y equals the natural log of secant of x plus c. I had to natural log both sides. There's no way to pull that c out of there. Okay, so that's my final answer. So if you have y prime, you're going to have to rewrite that as dy over dx, solve for that first, and then get your y's to one side, x's to the other side. Now we're going to do a couple of examples where we are finding the particular solution. And that means they've given us a point. So right after we integrate, we're going to plug 0 in for the x's, 2 in for the y. We're going to find out what c is equal to. Then we're going to solve for y. Okay? So first, integrate, 2, plug in. Then 3, solve for y. So here we go. Number 4. Get the y's together. So I will be dividing by y squared and multiplying by dx. When I integrate dy over y squared, that's going to be negative 1 over y. That's going to be 2x squared plus c. Okay. Now, I want to go ahead and substitute in as quickly as I possibly can. So I'm going to be plugging in 2 for my y, 0 for my x. Find out what that c is equal to. So c turns out to be negative 1/2. And then I'm going to plug that back in. I'm going to change colors here so we can see the difference. So that's negative 1 over y equals 2x squared minus 1/2. Okay, I need to go ahead and divide through by that negative. So that's 1 over y equals negative 2x squared plus 1/2. And then I need to flip it all over. So that's going to be y equals 1 over, and I'm going to put the 1/2 in front so I don't have that negative staring at me there. So that would be perfectly fine, or I can go ahead and get a common denominator, flip and multiply. If you do that, you've got 2 over 1 minus 4x squared. Either way is perfectly fine. But notice you are integrating it first, so I integrated right here. This is step 1. I plug it in immediately. That way I don't get tongue-tied when I solve for y. So there's my step 3 right there. Okay, let's try another one. So number 5, once again I'm going to go ahead and substitute that y prime for dy over dx. At the same time, I'm going to go ahead and move that natural log of x squared over. I'm going to divide by 2x and multiply by dx. So I've got dy equals natural log of x squared divided by 2x times dx. I'm going to simplify this a little. Remember, if you have a power on what you're taking the log of, you can bring that down in front, which is going to be huge because then I can cancel out that 2 on the bottom. So I have dy equals the natural log of plane x over plane 2. Sorry, plane x. So that 2 came down in front, and then I was able to cancel it out. Now when I integrate, I still have a u substitution to do. Remember, we don't know how to integrate natural logs, so it will have to be your u. Well, the derivative of natural log is 1 over x dx. Sorry, I was noticing that I had forgotten to write down my dx. Forgot to written. Nice talk. All right, so now we are ready. I've got my integral of dy equals my integral of du over u. No, I don't. You can tell I'm getting kind of tired. It's not du over u. Look, your dx is on top, or your natural log is on top, so you have u du. Okay, so now that we've got that all figured out, when I integrate, I've got y equals u squared over 2 plus c. Now, I can't go ahead and plug my value in because this is u. It's not x's. So, continuing on with step number 1, I've got y equals, remember what your x value is. Your x value is the natural log of x squared over 2 plus c. It's natural log of x quantity squared, not natural log of x squared. It's not what you started with over here because these two things are totally different. Now plug in. So I'm going to plug 2 in for your x. There are some values that they're going to expect you to know the value for. Natural log of 1 is one of them. The natural log of 1 is 0. So that makes our constant equal to 2. Then I'm going to plug that back in. Actually, right up here, sorry. And my final answer, it's already solved for y. So it was good to go. Good to go. All righty. Let's do another example. One last example. Okay. All right, so I want to get the dy dx all by its, or dy dt this time. Oh, they're being so creative. I'm going to add the t and subtract the 1. Divide through by t, and multiply by my dt. So I'm going to have t minus 1 divided by t dt. I want to simplify that before I integrate. So y squared dy equals 1 minus 1 over t dt. Integrate. For once, I don't have any u substitutions, so the integral, I'm going to have y to the third over 3 equals t minus the natural log of the absolute value of t plus c. Plug your values in, so I'm going to plug 1 in for my t's. So I'm going to plug 1 in here, 1 in here, and I'm going to plug 3 in here. So I end up with 27 over 3, which is 9. And then I have 1 plus c. So that means c has got to be 8. And then I'm going to plug that back into my equation. Last time I was there. So that was y to the third over 3 equals t minus the natural log of the absolute value of t plus 8. I'm going to multiply everything through by 3. And then I'm going to cube root. Remember, when you cube root, you don't have a plus or minus. Okay. So there's my final answer. Yay, go team. Now the last thing we're going to do deals with, they give us a differential equation, and notice this is our differential equation because it has a derivative, and they're going to give us possible solutions. And they're going to ask us, is it a solution to our differential equation? And we're going to have to find out if it is or if it isn't. You're going to look at your differential equation as a guide. It's going to tell you what you have to do to this equation. So note, I have a second derivative here, so that means I have to take the second derivative here. So I've got y prime is going to be cosine of x. The derivative of that, y double prime, is negative sine of x. And then you just plug it in. So where we have our y double prime minus y equals 0, I'm going to plug in my second derivative right there. I'm going to plug in the original function right there, and I'm going to see if it makes a true statement. Well, my second derivative is negative sine of x minus my original function, which is sine of x. That equals negative 2 sine of x, which is not equal to 0. So that would be no, not a solution. So let's try this little guy over here. Let's find the first derivative. So y prime is going to be negative 4e to the negative x. Y double prime is going to be 4e to the negative x, because remember, when you take the derivative of e to the negative x, that's going to be e to the negative x times negative 1. So plugging them in where they go, This goes in for my y double prime, so 4e to the negative x minus my original, which is 4e to the negative x. That equals 0, which does equal 0, so that is yes, a solution. Oopsie. Okay. So when they ask us, is it a solution, we need to find whatever derivatives they ask us to find and see if it works. Now this one I'm leaving up to you. Now this one's a little bit weird. You only have to find the first derivative and you're plugging that in. So when you look at this, you've got your y right here. So you're going to plug that in. Let me change colors here. Okay. You're going to find the derivative, which is going to be a product rule, and you're going to plug that in right here. Your y function right here, you're going to plug that in right here. So you're going to see if, once you plug in your derivative and your y, you're going to see if this side is equal to your x to the third times e to the x. Okay? So you try this one. When we get to class, we'll see if it was a yes, it is a solution, or no, it is not a solution. See you in class tomorrow.